Yeah, welcome. So in this lecture, see, first let us discuss the coding part of coding part for a single linked list, because last class we have discussed but we have not executed the code, right? So let us complete that execution. But before that, I would like to say a small updations in the insert function. So actually we have, if you see the insert function that we have discussed, which is used to insert a node after a node, okay, which is used to insert a new node after a node with the data part having the value after val. Okay, so this function will insert a node after a node whose node's data part contains the value after val. Okay, and this insert function actually we discussed in three cases. Case 1, inserting at the inserting if the linked list is empty. Case 2, we discussed inserting after the first node, okay, immediately after the first node, uh, and then case 3, anywhere else. Okay, uh, but what I am trying to say in the sense, actually all these three cases are not required. It can be done with just one case only, so that we should reduce the length of the code. Okay, first first point is, this is case 1, that is inserting in an empty list. Okay, first let us not have this case at all. We will not insert in an empty list. Okay, if the user want to perform if the user want to add some nodes in an empty list, then he has to use the function add node. He should not use insert. Okay, because our insert logic says that insert after so and so node. So this after, there should be a node with a particular value, this value after val. Okay, there should be a node with the data part holding the value after val. After that only we should insert. If there is no such node, we will not insert. So if the list is already empty, then it means that the list is empty, so there is no node with after val, so we won't insert. Okay, similarly, if you see the logic for inserting after the first node, uh, I think inserting after, the logic for inserting after first node and after any other node is same. Okay, so this part is also not required. Okay, so let us remove this, right? So now our logic is reduced. Okay, so it means that we have only so there is no else part, there is only this part. This is our logic. Okay, so 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 the logic of insertion will get reduced, right? So we just create a traverse pointer and the temp pointer. Temp is used to hold the starting address of the new node, and traverse will contain the traverse will point where head points, that is head is pointing to the first node, so traverse also will point to the first node. Okay, then what we do, then we should perform this while. What this while does, here we want to identify the node after which we want to insert, so that we are using this while loop. While traverse not equal to null, okay, from the first node onwards we are checking if that particular node's data is not equal to after val. If it is not equal, then we are making traverse to point to the next node, otherwise we break. Okay, so here the control will come out of the while loop under two cases. Either if you have identified a node whose data part is equal to after val, then also it will break, because else will be satisfied and it will break. Otherwise you are keep on traversing throughout the linked list and you have reached the last node, but still you are unable to find a node with data value equal to after val. Then at one point, when you say after reaching the last node, okay, assume currently traverse refers to last node, so traverse arrow next refers to last nodes next. Last nodes next will be what? Null. So then traverse will be assigned with null. Then again when it checks traverse is not equal to null, it is null, so it will come out. Okay, so for two reasons it will come out. Either it has traversed throughout the list and unable to identify a particular node with the value after val, then also it will come out. and also it will come out if you have already identified a node whose data part is equal to after val. Okay, so after coming out we should be able to recognize these two differences, why it came out. Okay, so after coming out of the while loop, we are first we are checking whether if traverse equal to null. If traverse equal to null, it means that uh, there is no node, there is no node with data part after val. Okay, there is no node with data part after val, that is the meaning. Okay, if traverse is equal to null, then we are printing there is no node with value percentage d after val and quit, because this is something like an abnormal termination, because user is trying to uh, insert uh, insert a node after a node which does not even exist. Okay, so this is something like an error. Okay, even if you want, you can type here an error. Okay, otherwise, okay, if the while loop comes out for other reason, then the second reason is it has already identified the node after which it should be inserted. Okay, so the new node is referred as temp. So temp arrow next is equal to traverse arrow next. Okay, uh, because the scenario here is what, the scenario is if the scenario is this is one node after which we want to insert, and this is currently the next node. Okay, and this is the new node, this is the new node. Okay, new node is referred using the pointer temp, new node is referred using the pointer temp. Okay, and the node after which insertion to be done, that is referred using the pointer traverse, that is referred using the pointer traverse. Okay, now traverse, now temps next should point where it should point, where it should point to where traverse next is pointing. Okay, so that we are saying temp arrow next equal to traverse arrow next. Okay, if temp arrow next, if traverse arrow next is pointing to the address 1000, then it means that this node starting address is 1000. Okay, when you say temp arrow next equal to traverse arrow next, then temp arrow next also will be 1000. Okay, so now temp arrow next is pointing to this node. Then what we are doing, traverse arrow next equal to temp, so traverse arrow next is equal to temp, so that will point here. Now this is broken. Okay, so now we have successfully inserted. So this is what we are doing. Okay, so this one change, okay, I want you to address. And so previously also the code is correct, but it is lengthy unnecessarily, but now I think we have reduced a lot, right? So you can just divide the code into only two parts. One is the required declaration for the two pointers, allocating memory and making traverse to point to head. Okay, then using the while loop, move to the particular node after which you want to insert, then perform the insertion. This is our core logic. Okay, this actually, this part you should understand thoroughly. Whatever we are doing before that is nothing but just to reach to that particular node and then what to do, right? So the logic part is only these two lines, right? Okay, fine. So let us see the execution of that code. Clear the screen. So I have saved the file as nano slist.c. So this is the file. So you can see it's, everything is same. Okay, yeah, so all these codes are there. I will delete this if and all these things which is not required, because we can do that with just one case. Okay, so let us remove, there is no this else part is also not required. Okay, so I think yeah, one bracket will be reduced here, right? Okay, right, so whatever I explained in that PPT, right? Okay, so this is the code. Okay, this is the node definition, head is pointing to null. This is the code for adding a new node. This is the code for inserting. Add will add the node at the end of the list. Okay, whereas insert will insert a node after a node whose data part is equal to after val, and delete is equal to delete a node with whose value is, whose data part contains the value val. Okay, and display, which is used to display all the contents, right? So in the main function, what we are doing, we are adding we are creating a linked list with 5 nodes. Okay, the first node's data part will be 1, second 2, 3, 4, 5, and then we are displaying it, right? Then we are inserting a new node 35 after the node 3. Okay, we are inserting a new node 35 after the node 3, and then we display that. And then we delete the node 3, and again we are displaying it. Okay, let us check how it's working. Saving, exit, gcc slist.c -o slist. It's compiled, execute /slist. So you can see here initially it is creating 5 nodes. Once next is pointing to 2, 3, 2 pointing 3, 4, 5, and 5 is pointing to null. Okay. Then next what we are doing, we are inserting a new node whose data part contains the value 35, and that is inserted between the node 3 and node 4, right? And then we are deleting the node 3. Okay, so node 3 is deleted, and then we are displaying. So now 2 is pointing to 35, okay, right, and 35 is pointing to 4, and 4 to 5, and 5 is null, right? Okay, so this is what I wanted to address before today's lecture. Okay, fine. So in today's lecture what we'll be discussing is, we'll be discussing about doubly linked list. Okay, so in the last lecture we have discussed singly linked list. So what is meant by a doubly linked list? See, doubly linked list also, it is a set of nodes. Okay, and each nodes, doubly linked list is a set of nodes or a collection of nodes, where each node contains 2 pods. What are they? Each node contains a data part and a pointer part, but now there will be 2 pointers. In a doubly linked list, each node will have a data part and it will have 2 pointers. What are the 2 pointers? There will be a next pointer, and also there will be a previous pointer. Okay, and the next pointer of a particular node will point to the next node, and the previous pointer of a particular node will point to the previous node. Okay, so this is the only difference between doubly linked list and singly linked list. In a single linked list, each node will have a data part and only one pointer, where the pointer will always point to the next node. Whereas in doubly linked list, each node will have a data part and it will have 2 pointers, where one pointer will point to the next node and the other pointer will point to the previous node, right? Okay, so you can visualize doubly linked list something like this. So each node, if you see, there will be a data part and there will be a pointer part. Okay, let us call the data part as D, and the previous pointer as P, and the next pointer as N. Okay, so like that, in every node there will be a data part, there will be a previous pointer, and there will be a next pointer, and the previous pointer will always point to the previous node, and the next pointer will always point to the next node. Okay, so like that you can have any number of nodes. Say the linked list may have 10, 20 or 30 or 100 nodes. Okay, so let us assume that our linked list contains only, say, 5 nodes. Okay, so if you take this particular node 3, its previous part, say this data part is 1. Okay, for our convenience, its data part is 2, this node's data part is 3, this node's data part is 4, this node's data part is 5. Okay, so if you see, node 3's next pointer will point to node 4, so this is next pointer. Okay, node 3's previous pointer will point to node 2. Okay, right? Similarly, if you see, node 4's next pointer will point to node 5. Okay, node 4's previous pointer will point to node 3. Okay, right? Node 2's next pointer will point to node 3. Node 2's previous pointer will point to node 1. Okay, fine. Node 1, now node 1's next pointer will point to node 2. Okay, okay, node 5's previous pointer will point to node 4. Okay, now comes the important question: where will the previous pointer of node 1 will point? Node 1 does not have any previous, right? So the previous pointer of node 1 will point to null. Okay, the previous pointer of node 1 will point to null, right? Similarly, where the previous pointer of node 5 will point, where the previous pointer of node 5 will point. So node 5's previous pointer will point to node 4. Okay, I mean where the next pointer of node 5 will point. Node 5 do not have any next. Okay, because node 5 is the last node. So node 5's next will point to null. Okay, so this is how you can visualize the linked list. So in a this is how you can visualize a doubly linked list. In a doubly linked list, every node will have a data part and 2 pointers. The next pointer will point to the next node, and the previous pointer will point to the previous node. Okay, for the last node, the next pointer will point to null, and for the first node, the previous pointer will point to null. Okay, so here also we have a head pointer. Here also we'll have a head pointer, and the head pointer will always point to the first node. Okay, head pointer will always point to the first node. If the list is empty, if there is no node in the linked list, in that case the head will point to null. Okay, these are common things which is applicable for any linked list. Initially, when you create a linked list, there will not be any nodes, then head will point to null. But the moment you create at least one node, then head will start pointing to that node, and head will always point to the first node, right? Okay, so previous pointer will point to the previous node, and next pointer will point to the next node. Okay, so why should we have these 2 pointers? What is the necessary? Why not we have just one pointer? Why not we just use singly linked list? Why should we use doubly linked list? Why 2 pointers? All these things. It is just we are maintaining these 2 pointers just for flexibility. What flexibility? Flexibility in terms of insertion, deletion, searching. Okay, searching an element in the list. All these operations can be done quite comfortably or easily if you have 2 pointers, because now you can travel in 2 directions, not only in 1 direction. Okay, it is not that you can move only from node 1 to node 2 and node 2 to node 3. You can also move in the reverse direction, node 3 to node 2, node 2 to node 1. Okay, like that also you can move, right? See, previously we have discussed about the advantages of linked list over arrays. Like linked list can insertion and deletion are can be easily performed in linked list, and that is the reason why we are going for linked list. Because if you do insertion and deletion with arrays, you have to move lot of data values from one location to another location. Such movements can be avoided with linked list. Okay, but there is also one drawback with linked list when compared with arrays. You know what is that? For example, in an array, if you want to access the ith element of an array, okay, you can just access the ith element of the array, something like this, a of I minus 1, which will give you the ith element of the array, right? Because a of 0 will give the first element, a of 1 will give the second element, so a of I minus 1 will give you the ith element of the array. It is as simple as that. Okay, so you assume that your array contains 1000 values. Say your array contains 1000 values, and this I represents 700. Okay, then you can access the 700th value just by this logic, a of I minus 1. Okay, a of 700 minus 1, which is a of 699, which is actually the 700th value. Okay, but that is not possible in linked list. Assume you have a linked list with 1000 nodes. Okay, let us assume a single linked list with 1000 nodes. So this is the first node and this is the second node. Like that you have many nodes, and how many nodes? The last node is nothing but the 1000th node. Okay, this is 1000th node, and whose next is pointing to null. Okay, fine. So this is the node 1000, right? Now assume that if you want to access the 700th node, then what you should do? Is there any way to directly access the 700th node? There is no way at all. We have only one reference we have. We don't have all the other nodes. There is no name for any nodes, right? Are we giving any name for node 1, node 2? No, nothing. We have only one pointer, that is head, which is pointing to the first node. Okay, anything you want to do, you have to use the head, and then only you can move. Okay, so now what we will do, probably you will create another pointer called traverse. Okay, and you will make traverse to point where head is pointing. So traverse is pointing where? It is pointing to first node, I mean head is pointing to first node. So now you will make traverse to point where head is pointing. So traverse also will point to the first node. And then you have to keep on move from one node to another node, next node. Like that you have to do 700 times. Okay? Maybe using a for loop or while loop, whatever it may be. Then only you can access the 700th node, right? So this is actually one drawback with linked list. Okay, right? But so why we are using doubly linked list, all these things means still the drawback exists, but still we have some degree of flexibility. Okay, say I am currently in 800th node, then if I want to go back, then I need a backward link. Okay, so that is possible with doubly linked list, but that is not possible in a singly linked list. In a single linked list, always you have to move only in the forward direction, right? Okay, so it's just for this flexibility we are going for doubly linked list. So how will we define a node in doubly linked list? It is very similar as that of how we defined in single linked list. Struct node int data. Now we need two pointers, struct node star previous and star next. Close the bracket, put the semicolon. Okay, how do we define head? Struct node star head is equal to null. Why null? Because initially the linked list is empty, there are no nodes, so it is null. That's it. Okay, then let us see the logic for adding nodes to the linked list by using a function. So let us assume there is a function called add node. This function is a void function, that is it won't return any value, it returns nothing. It takes one argument called val, which means that you create a new node, and that node's data part will contain the value val, and its next will be null, and its next pointer will be null, and add this node to the end of the linked list. That is what it says, and add this node to the end of the linked list. Okay, and its previous pointer, we are talking about doubly linked list. Okay, and its previous pointer will point to the previous lost node. Previously whatever is the lost node, there the previous pointer will point. Okay, previously this is the lost node. Now after adding this new node, this becomes the lost node. Okay, so the new node will be always added to the end of the list. Okay, and the previous lost node's next pointer should point to this node. Okay, are you getting? So we are going to add a new node, that new node's next will be null, that new node's previous should point to the previous lost node, and the previous lost node's next should point to the new node. Okay, so this is what is expected to be done. Okay, right? Fine. If the list is empty, so this is the case if at least one node is in the list, in the linked list. If the list is empty, at that time if you want to add a new node, then what you should do? Again create a new node, the data part will be value. Okay, now this is the only node, there is no other nodes, and its next will be null, because currently there is no other nodes, and head should point to this node. In that case, if this is the first node, then you have to make head to point to this particular node, and its previous also should point to null. Okay, because what is the understanding? The first node's previous should point to null, and the last node's head should, the first node's previous should point to null, and the last node's next should point to null. Now this is the first node, and also this is the last node, so its previous is also pointing to null, and its next is also pointing to null. Okay, fine. So what we do here, first we declare two variables, two pointers for node. One is traverse, the other one is temp. Okay, so temp is for the new node. Okay, so we are saying that temp is equal to struct node star malloc size of struct node. Okay, which will allocate space for the new node. Okay, and that new node is getting pointed by the pointer temp, and then we are saying temp arrow data is equal to val. Whatever the value, the data part is assigned with that value. Okay, so this statement basically, it has successfully created a node with the two pointers, right, next and previous. So this statement temp arrow data is equal to val. It puts the val in the data part. Okay, temp arrow next is equal to null. So what it does, it will make next as null. Its next is null. Okay, traverse is equal to head. Currently what is head? Let us assume this is the first node we are adding. So if this is the first node, then head will be null. If head is null, then traverse also will be null. So this statement, what it will do, it will just make traverse is equal to null, because head is null, because this is the first node you are adding. So there is no other nodes in the linked list previously, so it is null, right? It is null. Then you created a new node, but there are two cases. One is adding if this is the first node, then the logic to add is different. If this is any other node, then the logic to add is different. Okay, so how do we check whether this is the first node or not? By this we can check. If head is equal to null, if head is equal to null, then it means that this is the first node. In that case, then we say head is equal to temp. Okay, so this is the new node, is nothing but it is referred using the pointer temp. Okay, this is referred using the pointer temp. Previously head is equal to null, now we say that head is equal to temp. So it means that now head is pointing to this particular node. Okay, if head is pointing to this node, it means that this is the first node. If this is the first node, its previous also should be null. So we are saying temp arrow previous equal to null. Okay, right? So this is the case if this is the first node. If this is not the first node, then what should we do? If this is not the first node, then we should assume this is not the first node. Whatever the new node you created, that's not the first node. Already there are some nodes in the linked list. So already some 2-3 nodes are in the linked list, and every node's next is pointing to the other node, something like that. Okay, so the first node's previous will be null, right? Okay, so already 2 nodes are in the linked list, right? So the second node's next is pointing to null. Okay, and now you created another node. Now you have created another node, and this is our new node, and this is referred using temp. Okay, now where this new node should be added? This new node should be added at the end of the list. So for that, first you have to traverse through the end of the list. Okay, for that we are doing while traverse arrow next not equal to null. What is traverse? Traverse and head both will point to the first node. Head is pointing to the first node, and traverse is also pointing to the first node. So it checks while traverse arrow next not equal to null. So traverse is pointing wherever head is pointing. So that means it is pointing to the first node. So its first node's next is null. No, it's not null. Then traverse equal to traverse arrow next. Again it will go. So now traverse, instead of pointing the first node, it will point to the second node. Is this node's next is null? Yes, it is null. Okay. So even if there are 100 nodes, it will rotate accordingly, and it will finally traverse will point to the last node. Okay. Now we reached the last node. After last node, we should add the new node. Okay. Now what are the 2 connectivities we have to give? The last node, the current last node's next should point to the new node. Okay, and the new node's previous should point to the whatever the previous whatever the current last node. Okay, after adding this, then this new node will become the last node, right? So what we are doing, traverse arrow next is equal to temp. What is traverse? This is traverse. Its next is equal to temp, that is it will point here, and then we say, and then what we say, temp arrow previous equal to traverse. So its previous will point to traverse. Okay, temp's next is already null. You can go back here and check. Whenever we create a new node, we are making its next is null, because new node, we are adding new nodes, so always we are adding at the last. So you can while creating itself, you can make its next as null. Okay, so this is how we add the new node to a linked list, right? To a doubly linked list. Okay, fine. So there are 2 pointers. This is the actual core logic. If you understand this, I think everything is done, right? So if you want me to explain again, so assume that already there are 2 nodes are there. Okay, so and this is the new node which we are going to add, right? The new node is referred as what? Traverse. sorry, temp, using the pointer temp, we are referring to the new node. Okay, and the current lost node, this is the current lost node, that is referred as traverse, that is referred as traverse. Okay, so these are the pointers. First node is pointing, first node's next is pointing to second node, second node's previous is pointing to the first node. Okay, first node's previous is null. Okay, first node's previous is null, and this is currently the second node is the lost node, so its next is null. Okay, but now what you have to do, we have to make that traverse is the current lost node, its next should point to temp. Okay, so its next should point to temp. So what statement you have to write? Traverse arrow next equal to temp. So that's what this statement. And then you have to make the temp's previous should point to traverse. So temp arrow previous equal to traverse. Okay, so no more this next is null, its traverse next is now temp. So this is temp arrow previous equal to traverse. Okay, so this is the core logic for adding a new node to the end of a doubly linked list, right? Okay. Next, let us discuss how to insert node into a doubly linked list. So for that, let us write a function void insert. It takes two arguments, like how we discussed for single linked list, the same fashion. One is the new val, that is whatever the new node you are going to create it, that whatever the new node which we are going to create, what should be the data part of that particular node, that is what new val. Okay, and the next parameter is after val, which represents the data part of the node after which we want to add the new node. Okay, the second argument represents the data part of the node after which we want to add the new node, right? So these are the pointers we are creating, traverse and temp. Temp is for new node. So for temp, we are allocating space, and that memory location will be pointed by temp. Okay, and this is what the new node is, and its value should be temp arrow data should be new val. Its value should be new val. Okay, and traverse should point where? Traverse will point where head is pointing. Traverse will point where head is pointing. Okay, then assume that say assume that the list contains 3 nodes. Currently the linked list contains 3 nodes, node 1, 2 and 3, right? These are the nodes we have, let us assume, in a simple case. Okay, so this is node 1, this is node 2 and this is node 3. So 1 is the first node and 3 is the last node. So 3's next will point to null. Okay, I will represent null as a cross symbol. Okay, and 1's previous will point to null because 1 is the first node. Okay, 1's next will point to, so this is null, this is means it's null. Okay, this cross represents null. Okay, so 1's next will point to node 2, right, and 2's previous will point to node 1, 2's next will point to node 3, and 3's previous will point to node 2, right? So this is our linked list so far, right? Let us assume. Okay, now assume that this new val is 22, new val is 22, and this after val is 2. It is after node 2 we want to add this new val. Okay, so this statements, what it will do, it will already create, it has already created a new node, and that new node's data part is what? 22. Okay, new node's data part is 22. We don't know what is its next and previous. So far we have not assigned anything. Okay, and traverse is equal to head. What is head? What is head? Head, let me call head as h. Head is pointing to first node, so traverse will point wherever head is pointing. So traverse also will point to the first node. Okay, but where should we insert? We should insert after second node. So we should move to the node after which you want to insert. For that we are writing this loop. While traverse arrow next, while traverse not equal to null. Is traverse is equal to null? No, it's pointing to the first node, it's not null. If that is the case, then check. If traverse arrow data not equal to after val, what is traverse arrow data? 1. Is it equal to after val? After val is 2. No, it's not equal to after val. Then what you should do? Traverse equal to traverse arrow next. So it means that no more traverse is pointing here. Traverse is pointing to traverse arrow next, which means second node. Okay, so the else part will not execute. Again come here and check, is traverse equal to null? No, currently traverse is pointing to the second node. Is traverse arrow data is equal to after val? Yes. Traverse arrow data is what? 2. What is after val? That is also 2. Yes. So is it, here we are checking, is it not equal? No, it's equal. So it means the if fails, the else part will execute. So it breaks. It will break out of the loop. Okay. But the breaking can happen for two reasons. Okay, either even if there is no such value, assume this after value is 5, then you will keep on loop and finally you will break because traverse will become null. In that case there is no such value, there is no node with data part 5, okay, to insert a new node after that node, right? So for that reason also it may come out, or it may come out because it has identified that particular node after which the new node should be added. Okay, so that we have to discriminate properly. For that we are using this if condition. Immediately after coming out of the while loop, we check if traverse equal to null. If traverse equal to null, then it means that you are unable to locate a node whose data part is equal to after val. So which means then we say there is no node with data part after val, and we exit. Okay, otherwise comes the actual logic. Okay, let us discuss that. Now this is the new node. This new node is referred using what? Temp. So this is the core logic. Okay, now how should we add this temp? Temp should come in between node 2 and 3. Now node 2 is referred as traverse. Okay, so what does it mean? Temp's next should point where? It should point to node 3, which is what? Which is nothing but traverse next. Okay, so temp arrow next is equal to what? Temp arrow next is equal to traverse arrow next, because temp next should point to node 3. But how do we refer node 3? We don't have any direct pointer to node 3. We have only pointer to the node after which we want to insert. So traverse. So traverse arrow next is nothing but what? Traverse arrow next is pointing to node 3. Okay. So temp arrow next is equal to, temp arrow next will point wherever traverse arrow next is pointing. Okay, is equal to traverse arrow next, so that will provide this connection. That will provide which connection? This particular connection. Okay, then what should we do? Temp's previous should point where? Temp previous should point to traverse. Okay, temp's previous should point to traverse. Okay, so temp arrow previous is equal to traverse. Okay, so this, what it will do, this will provide this connection. Temp's previous is now pointing to traverse. Okay, right? What else we should do? We should make temp traverse next to point to temp. Okay, we should make traverse next to point to temp. Okay, and also we should make this node 3's previous should point to temp. Okay, now how will we do that? There are two things we should do. One is traverse next should point to temp. This traverse next pointer should point to temp, and this node 3's previous should point to temp. Okay, so how can we do that? Which one we should do first? Actually we should make the node 3's to point to traverse first. Okay, because why, I'll tell you. Okay, because the reason is yeah, see, actually what we should do in the sense, this we have to make it to point to the node 3's previous should point to temp, and that code should, you have to write that code first. Okay, you have to write that code first. Okay, Yes, okay, but actually here I have not written in the proper order, but that order is important, right? Let me change that order. Okay, let me change that order. See, first what we are doing, temp arrow next is equal to traverse arrow next. Okay, that means the new node is pointing to the node which is after the traverse node. Okay, then traverse arrow next is equal to temp. Okay, traverse arrow next is equal to temp. Okay, this actually we should not do here, this we should do lost. Okay, the reason I will tell you. Okay, then what you have, you can do these two things first. We can do anything for temp arrow next is equal to traverse arrow next, and temp arrow previous equal to traverse. This is fine. Okay, so this means that you already inserted a new node, so the new nodes next is pointing to the node which follows the traverse. Okay, and the new nodes previous is pointing to traverse. Okay, fine. After that, what we have to do, we have to give this reverse connection. What is that reverse connection? The node which is the right side of the new node, okay, that should point to the new node which is temp. Okay, for that this is the statement. How we will refer to the node which is right side the new node? We have to refer like this: traverse arrow next. What is traverse arrow next? See, if you go back to this diagram, still traverse refers to node 2. Okay, still traverse arrow next is pointing to node 3. Okay, so traverse arrow next is nothing but node 3. Traverse arrow next is nothing but node 3. Okay, and node 3 is previous. Okay, node 3 is previous, now should point to temp. So that we are writing this statement: traverse arrow next is equal, traverse arrow next arrow previous equal to temp. Okay, traverse arrow next arrow previous equal to temp. Okay, but there is a condition. We should do this only if traverse arrow next is not equal to null. Okay, that means, what does it mean? Insertion can happen at any place, right? Now we are assuming we are inserting between node 2 and 3, but assume if node 2 is the last node. If node 2 is the last node, then in that case, if node 2 is the last node, in that case, then this new nodes next, I mean the if this is the last node, if node 2 is the last node, then in that case there is no node in the right side of the new node, and there is nothing to point, and its previous pointer need not point here because there is no node at all. Then where comes the previous pointer? Okay, so that is the reason here we are checking this condition. If traverse arrow next is not equal to null, okay, traverse refers to which node? Node 2. If node 2's next is not equal to null, then do that. Okay, if node 2's next is equal to null, it means that then the new node is the last node. Are you getting? If it is not equal to null, then whatever the current next node of traverse, that node's previous will point to temp, right? Okay, I think you are following. After that, this statement will come: traverse arrow next equal to temp. So what is traverse? Traverse is the node 2, its next will point to null, its next will point to temp. Okay, so when you do that, okay, so when you do that, what happens when you do that? uh, so the point I'm trying to say is, so first you will write this 2, then you have to check what if traverse arrow next not equal to null. Why we are doing this? Because to ensure that uh, the traverse is not the last node. Okay, if traverse arrow next not equal to null, if it is not equal to null, then it means that there is some, after traverse there is a node. Okay, and before and in between traverse and the node which comes after traverse, in between that we are going to insert the new node. Okay, so if it is not equal to null, okay, if it is not equal to null, okay, then what you should do? Then traverse arrow next arrow previous. Okay, traverse arrow next is what? node 3. Traverse arrow next is node 3. Okay, node 3. And arrow previous is node 3 is previous. Node 3 is previous. Okay, node 3 is previous equal to temp. Okay, traverse arrow next, arrow previous okay, or you can say it is temp, so equal to temp, right? Or I'll change the color, it's not working, I don't know. So traverse arrow next, arrow previous is equal to temp. This is what you have to write here, right? Okay, so when you do this, this connection is established. Now this previously, this is what traverse arrow next is node 3, its previous is now pointing to traverse. Now this connection we are breaking and we are making to point to temp. We are making it to point to temp. Okay, right? Similarly, you should provide one more connection. What is that? Traverse arrow next also should point to temp. Traverse arrow next is now pointing to node 3. So next what you should write, at last we should write traverse arrow next is equal to traverse arrow next is equal to what? Traverse arrow next is equal to temp. Okay, traverse arrow next is equal to temp. So this will break this connection. Now traverse arrow next will point to temp. This is temp. Okay, this is this node only we are referring as temp, right? So this is the logic, this is the core logic. Okay, this 4 lines if you understand, then most of the job is done. Okay, for insertion, right? Okay, if this is the last node, then obviously there is a there is nothing, this connection is not required. Okay, there is no next node, so there is no previous, so this part will execute only if the new node is not the last node. Okay, right? So this is the core logic for insertion, right? Okay. Here so this while loop is we are walking through the while loop, okay, which we have discussed, and this is the logic. Okay, temp arrow next equal to traverse arrow next, temp arrow previous equal to traverse. If traverse arrow next not equal to null, then traverse arrow next arrow previous. So this part you should be clear. Okay, this refers to the node which follows the traverse, and that node's previous pointer will point to the current new node. Okay, and this should be executed only if the current new node is not the last node. Okay, right? And then finally traverse arrow next is equal to temp, that is the previous node, whatever the node after which we want to insert, that is what traverse is. That nodes next should point to temp. Okay, so that's it about insertion. Okay, next comes deletion. So this is how we provide for deletion. The function name is delete node, and it is a void function. It takes one value as argument, so which means that the node whose data part is equal to val, that node is to be deleted. Okay, so we create 2 pointers, one is traverse, the other one is previous. Here we need to identify the node which is to be deleted and also its previous node. Okay, so that we are maintaining these 2 pointers. Okay, and traverse is equal to head. So this logic is almost similar like what you call our single linked list, only the double connectivity part you have to check. Okay, so if so again here there are 2 cases. If you want to delete the first node, then the logic is different. If you want to delete any other node, then the logic is different. Okay, so how do we know that whether the node which we want to delete is the first node or not? So for that we are writing this. First we are making traverse to point to head, then we check if head arrow data is equal to val. If head arrow data is val, then it means that this is the first node which you want to delete. Then it means that we don't want the first node. The first node should be deleted. Okay, then head is not the first node, then head should be second node. So head is equal to head arrow next. So second node becomes the head. Okay, now if second node is head, okay, then what does it mean? It means that the first node's previous should be always null. So now the second node's previous should be null. Okay, so we give this statement. Now the second node is head, so head's previous we are making null. Okay, because previously head's previous will point to the first node. Now that first node we want to remove. Okay, so head arrow previous equal to null. But before doing that, we are checking if head is equal to null. Why we are doing this? Assume there is only one node in the linked list. Assume there is only one node in the linked list with the value 1. Okay, its next is null, its previous is also null. Okay, and say that user want to delete that node. Okay, if user want to delete that node, then it checks if head arrow data equal to val. Yes, user want to delete this particular node, then head is equal to head arrow next. Initially head is pointing where? Initially head is pointing to this node. Okay, its data is 1 and user wants to delete that node. Okay, then head is equal to head arrow next. So what is head arrow next? Null. So now head is what? Null. Now head is what? Null. Okay, so now head is not pointing to the second node because there is no second node at all. I mean, there is no more nodes. Okay, so head is already null. Okay, if there is only one node, then you need not do this thing. Okay, that's what we are checking. If head is not equal to null, if there is some other node, then head will point to that node. Okay, then head, instead of pointing to the first node, then head will point to the second node. But the second node's previous pointer, previously it will be pointing to the first node, but it should not point. It should point where? It should point to null. Okay, and that is the reason why we are writing this statement. But before writing, check whether updated value of head is not equal to null or not. If it is not null, then do this. Okay, and now the previous first node is also getting pointed by traverse. The previous first node is also getting pointed by traverse. Okay, so what we say? Free of traverse. We free the space. Free up the space. Okay, so this is the logic for deleting if the node is the first node. Else, if the node is not the first node, if it is something else, then first we have to locate the node. For that we are writing this else block. This logic is very similar as that of insertion. While traverse not equal to null, traverse is currently first node as long as it is not null. Traverse, and we check if traverse arrow data not equal to val. If traverse arrow data is not equal to val, then what we say is previous equal to traverse and traverse equal to traverse arrow next. Okay, that is previous will always point to the previous node and traverse will point to the current node. Okay, like that we update the pointer. How long we update? Until you don't find the node which is to be deleted, that is the nodes whose data part is not equal to val. Okay, the moment you find the data part whose value is equal to val, the control will come out. You break. Okay, but the control comes out of while loop again for two reasons. Either you traverse throughout the list and you are unable to find a node whose data is equal to val, that is one reason, or you have found the node whose data is equal to val which is to be deleted, right? So we have to find out why it has came out. So first we are checking if traverse equal to null. After immediately coming out of the while loop, if traverse equal to null, then it means that you have traversed throughout the linked list but you couldn't find a node whose data part is null. So in that case we say that there is no such node with data so and we exit. Otherwise we have to perform the deletion. Okay, so how will we delete? Let us try to understand. Let us assume again a simple case with 3 nodes. One, because already we have discussed the case for deleting the first node. Let us assume there are 3 nodes. Okay, let us assume the node which we want to delete is the node 2. So this is node 1, node 2, and this is node 3. Okay, so node 1's next is pointing to node 2, node 2's previous is pointing to node 1, node 2's next is pointing to node 3, node 3's previous is pointing to node 2, node 3's next is null, node 1's previous is null. Okay, head is pointing to node 1, head is pointing to node 1, Okay, traverse is pointing to node 2, because after this much code, traverse is pointing to, at this point traverse is pointing to node 2 and previous is pointing to node 1. Okay, the node to be deleted is whatever which is pointed by traverse. Okay, and the previous node is previous. Okay, now how we will delete? Now node 1's next should point to node 3, right? And node 3's previous should point to node 1. That is what we want to do. So what logic you will write? So what should we write? Node, how will we refer node 1? Previous arrow next should be what? Previous arrow, node 1's next should point to node 3. So how will we refer to node 3? Previous arrow next is equal to traverse arrow next. That's all. Previous arrow next is equal to traverse arrow next. Okay, and then what should we do? Node 3's previous should point to node 1. Okay, so how we will do that? Node 3's previous should point to node 1. Okay, so again here you should write which statement. How will we refer to node 3? Again, like how we did in insertion, the same way. Node 3 is, how can we refer to node 3? Traverse arrow next, by that we can refer to node 3. Traverse arrow next is nothing but node 3, but that node's previous should point to this particular previous node. Okay, so there are two previous we are using, so you need not get confused. Otherwise for this previous we can give some other name, that's not an issue. Okay, so this is a part of the node. Okay, this is a member inside the structure. So even if you give same name, I don't think it will be an issue, but if you feel if you want, you can give a separate name. Okay, so traverse arrow next arrow previous is equal to previous. Okay, so this is what we should do. But before giving this condition, again you should check what you should check. Assume there is no node here, assume there is no node 3, node 2 is the last node, then you cannot do this, right? Because there is no next node, then how could we access the next node's previous? Okay, so this you should do only if traverse arrow next is not equal to null. If this is possible, only if traverse arrow next is not equal to null. Okay, so do this only if traverse arrow next is not equal to null. So I represent null like this for quick doing. Okay, so this is the logic. Previous arrow next is equal to traverse arrow next, and then traverse arrow next is equal to traverse arrow next arrow previous equal to previous. But before doing this, check if traverse arrow next is not equal to null. Okay, then finally what? Free of that particular node which you want to delete it. So that's it, the logic for delete. Okay, then what? Displaying is very similar to that of singly linked list. The same logic you can use, right? And you can write a main function something like this. Create a variable I. Okay, run the loop for 10 times and call the function add node with I plus 1, which will create 10 nodes. The first node data will be 1, second node 2, third will be 3, fourth will be 4, like that, so on and so forth. Up to 10th nodes data will be 10. Then display that, which will display all the 10 nodes like 1, 2, 3, like that up to 10. Okay, up to 10, and also it will say that after 10 it is null. Okay, so like that it will display, right, as per our previous logic for display, right? Okay, then we insert a new node. The new node is called as 11. This is inserted after the node 1. Okay, by calling the function insert, we insert a new node. The new node's data part will be 11, and that new node is inserted after the node 1. Okay, and then again you display, right? Then we insert a new node, and this new node's data part will be 75, and this new node is inserted after the node 7. Again you display. Okay, then we delete the node 9, and again you display. Okay, that's it. So let us see the code. Okay, let us execute the code. Yes. So the file name is dlist nano dlist.c. So this is the code. Whatever we have discussed, it's the same code. I don't think any changes here, right? Yeah, maybe that. What is that? Yes. Insert this part is not required, which I will delete. So this is the end of while. This is if. This is, I think this is not required. And yeah, and here also this statement should come traverse arrow next equal to temp. It should come at last. Okay. Yeah, because this we are doing first traverse arrow next arrow previous. Okay, so this should come at last. Arrow next is equal to 10. So this is the code for deletion. Okay, delete at the beginning and delete anywhere else. And this is for display, same as that of I mean singly linked list. There is no difference, and that's it. Okay. You can see it is 1 2 3 4 5 6 7 8 9 10. Okay, then we are inserting 11 between 1 and 2. Okay, then we are inserting 75 between 7 and 8. Then we are deleting the node 9. So after 8 it is 10, right? So that's it. Okay, about doubly linked list. Okay, so you should practice all these things. Okay, so then only you'll feel the confidence. Okay, fine. So this topic is also included for the test one, right? So there will be questions on this. Maybe I may give a function, or I may give a function and I may not give some lines. I may ask you to find out those lines. Okay, or certain things which we have not did. For example, search we have not did. Say I want you to write a function to search whether a particular node with a given data value exists or not. You should say whether it exists or does it exist. If it is existing, at which position it is existing. Okay, all these things, right? So this type of questions you may expect. Okay, fine, let us stop here. Thank you.